Good morning, grade 12. Hope you are all doing fine. This is Miss Pamela Teeny giving the physics course. Today we are going to continue chapter 18, section 1, refraction of light, which is on page 492. First of all, I'm going to correct the homework and then we will continue. So if we read on page 494, number 1, the question is, a laser beam in air enters ethanol at an angle of incidence of 37 degrees. What is the angle of refraction? So the given is N1, which is N air, equal 1.0003, N2, which is N ethanol, it's equal to 1.36, and angle 1, which is the angle of incidence, equal to 37 degrees. We need to find angle 2, the angle of refraction. So we do sine minus 1 into N1 sine angle 1 over N2. We put the values, so it's equal to sine minus 1 into 1.0003 times sine 37 over 1.36. The answer is 26.27 degrees. So here we can also draw the refraction so we can see the problem in a simpler way. So in the figure to the left you can see light is passing from air to ethanol. The incident angle is 37 degrees and the refraction angle is 26.27, which is less than the incident angle. Now number 2. As light travels from air into water, the angle of refraction is 25 degrees to the normal. Find the angle of incidence. So the given is that N1 is N air, equal to 1.0003, N2 is N water, equal to 1.33, and the angle of refraction, which is angle 2, is equal to 25 degrees. They want us to find the angle of incidence. So we use the equation shown in front of you. Angle 1 is equal to sine minus 1 into N2 times sine angle 2 over N1. So it's equal to sine minus 1 into 1.33 times sine 25 over 1.0003. The answer is 34.18 degrees. So we can see in the figure to the left this refraction. Light is passing from air to water. The angle of incidence is 34.18 and the angle of refraction is 25, which is also less than the angle of incidence. Number 3. Light in air enters diamond at 45 degrees. What is the angle of refraction? So in the given we can see that N1 is N air equal to 1.0003, N2 is N diamond equal to 2.42, and the angle of incidence, which is angle 1, is equal to 45 degrees. We need to find the angle of refraction, so we use the equation sine minus 1 into N1 sine angle 1 over N2. We put the values and the answer is 16.99 degrees. So we can see in the figure to the left, as light passes from air to diamond, the angle of refraction is less than the angle of incidence, which is 45 degrees. Number 4. A block of unknown material is submerged in water. Light in water enters the block at an angle of incidence of 31 degrees. The angle of refraction of the light in the block is 27 degrees. What is the index of refraction of the material of the block? So here, in the given we have N1 is equal to N water equal to 1.33 because they said that light in water enters the block. So light is in water at first and then it enters the block of unknown material. Angle of incidence, which is angle 1, is equal to 31 degrees. Angle of refraction, which is angle 2, is equal to 27 degrees. And they want us to find the index of refraction of the unknown material. So first we can draw the figure to make the problem simpler for us to solve. So we can see light passing from water into the unknown material. The angle of incidence is 31 degrees and the angle of refraction is 27 degrees. So to find N2, we use the equation N2 is equal to N1 sine angle 1 over sine angle 2. N2 is equal to 1.33 times sine 31 over sine 27. So N2 is equal to 1.508. Finally, in number 5, they asked us, light travels from air into another medium. The angle of incidence is 45 degrees and the angle of refraction is 27.7 degrees. What is the other medium? So in the question, they didn't ask about the index of refraction of the other medium directly, but they asked what is the other medium. In order to know what is this other medium, we need to find N2. So we do as we did in number 4, and we use the equation N2 is equal to N1 sine angle 1 over sine angle 2. We put the values. N1 is an air because in the problem they said light travels from air into the other medium. And angle 1 is the angle of incidence, 45 degrees. Angle 2 is the angle of refraction, 27.7 degrees. After calculation, we find that N2 is equal to 1.52. And if we look at table 1, page 493, from which we are getting the indices of refraction, we see that float glass has the index of refraction of 1.52. So the other material is float glass. Now we will continue the section. We are going to talk about total internal reflection. Total internal reflection is a phenomenon that occurs when light traveling from a region of lower index of refraction strikes the boundary at an angle greater than the critical angle, such that all light reflects back into the region of the higher index of refraction. So we can conclude that for total internal reflection to occur, we have two conditions that must be applied. The first is that the light must be traveling from a region of higher index of refraction to a region of lower index of refraction. So N1 must be greater than N2. The other condition is that the angle of incidence should be greater than the critical angle. In this way, the light totally reflects. So light doesn't pass from the first medium to the other. It reflects in the region of the higher index of refraction. So as we said, in order for total internal reflection to occur, the angle of incidence must be greater than the critical angle. So what is the critical angle? The critical angle is the angle of incidence beyond which rays of light passing through a denser medium to the surface of a less dense medium are no longer refracted but totally reflected. So it is the angle that is specific and it differs according to different mediums. So when the angle of incidence is greater than this specific angle, the light doesn't pass to the less dense medium. Rather, it totally reflects inside the more dense medium. And now you are going to see what we talked about. So look at the figure in front of you. We start from the left. If light hits the boundary perpendicularly, which means parallel to the normal, it continues as it is. It doesn't change its direction. Then, if light hits the boundary at a certain angle of incidence that is less than the critical angle, it refracts, it changes its direction. Then, if light hits the boundary at the critical angle, the light continues parallel to the boundary. Finally, if light hits the boundary at an angle greater than the critical angle, the light totally reflects, so it doesn't pass to the other medium. It remains in the more dense medium. To calculate the critical angle of each case, you use the following equation. Critical angle is equal to sine minus 1 into N2 over N1. Angle is measured in degrees. N2 and N1 do not have a unit, as we mentioned before, and sine minus 1 is shift sign on the calculator. By rearrangement of this equation, we can also find N1 and N2 if we know the critical angle of the medium. So N1 is equal to N2 divided by sine angle critical, and N2 is equal to N1 times sine of critical angle. Example. Does total internal reflection occur when light passes from diamond N equal 2.42 to water N equal 1.33 if it hits the boundary at an angle of 50 degrees? In order to solve this problem, first we need to look at the indices of refraction. If N1 is greater than N2, we proceed. But if N1 is less than N2, we directly say that total internal reflection is not possible. So in order to solve this exercise, first we find the critical angle of light passing from diamond into water. Critical angle is equal to sine minus 1 into N2 over N1. So critical angle is equal to sine minus 1 into 1.33 over 2.42. It is equal to 33.33 degrees. Second, we compare the angle of incidence to the critical angle. In this case, the angle of incidence is greater than the critical angle, so total internal reflection occurs. We can see in the figure in front of us, as light is passing from diamond into water, if it hits the boundary at an angle of 50 degrees, it totally internally reflects. So it doesn't pass into water, it doesn't refract, however it reflects and it remains in diamond. But if the angle of incidence was less than the critical angle, then total internal reflection doesn't occur. As a homework, please solve the following questions. 1. Will there be total internal reflection if light in water hits the boundary with float glass at an angle of 49 degrees? 2. Will there be total internal reflection if light in quartz hits the boundary with water at an angle of 35 degrees? 3. Find the angle of refraction of light that hits the boundary between quartz and a material where light moves at a speed of 1.25 times 10 to the power 8 meters per second at an angle of 31 degrees. Note, use Table 1, page 493 to find the indices of refraction. Thank you and good luck.